Wednesdays, we wear pink. I got my pink bow tie. Fun fact, actually, real quick about this bow tie. I got it for free. Okay, my favorite price point. So I had the blessing and pleasure of being in some weddings when I was in college, especially for a bunch of my college buddies. So I was a groomsman for some different weddings. And the downside to being a groomsman is you have to pay money to rent a suit. And renting a suit is not as cheap as it should be, in my opinion. And so thankfully, they all did it theirs through Men's Warehouse, and so I'm like, well, I might as well sign up for the rewards program. And so I ended up spending enough by renting suits to where I got a free $50 to spend there. And I'm like, boom, bow tie and a pair of socks. So let's go. So it would have I wouldn't have gotten it had I not signed up for the rewards program. I didn't pay $50 for the tie.
You just didn't pay money.
But I got the tie for free after I did all the rentals. I could have just gotten the rentals and not done anything. It's like buy two, get one free. I got the third one free.
You guys have to clarify.
Okay. Anyway, so you guys will be able to factor trinomials when A is not 1. We're going to learn what that means, and we're going to learn how to do that. So in our homework that we just checked in the last section, we learned how to factor 4-term polynomials. That was when there were 1, 2, 3, 4 terms. Trinomials is the one that's going to be how many? 3, okay? Isaac, put it away. Jaden, put it away. All right. If it's an emergency, let me know, okay? Otherwise, we'll have it wait for now, okay? So, we're going to learn trinomials when the leading coefficient is not 1. We're going to learn what that means, okay, as well. Now, guys, we need to dial it back in. Thank you. So we have the standard form for quadratics. Quadratics, whoa, it's a new word to us. It's big and fancy, okay? Well, that is something we're going to learn next chapter, okay? Ax squared plus bx plus c. Quadratic just means that the highest exponent we see is a power of 2. Okay, do you guys remember linear equations? They graphed them and it made a straight line. The exponent was 1. Okay, y equals x plus b, stuff like that. Okay. Quadratic is another type of equation, okay? That would give us the graph and all this kind of stuff too. But the highest power is 2. Have we seen expressions pretty similar to this so far in this chapter? In last chapter?
Yes.
Yeah, I think so. So we're just giving it a name. So if we have, this is our standard form for quadratics. Ax squared plus bx plus c. We have the x squared first, the x to the first second, and the one without an x last. A, b, and c are just coefficients. They're just normal numbers. Whereas the x's stay as x's. So here, if we have 3x squared minus 5x minus 2, notice we still have the x squared and the x and no x. So here, what is our a? Just 3. Very good. 3 is in place of a. What is b? Negative 5. Good catch. It's negative 5. In our standard form, it's plus b, but here it's minus 5. So what's that make c? Negative 2. Very good.
But in the standard form of quadratic, it's plus c.
Correct. So in the standard form, it's plus c. That's why it's a negative 2 here. Because it's like plus and negative 2, which is just minus 2. Yep. So on 2, don't blurt, but go ahead and write down what you think A, B, and C are. Yeah. Not quite. Thank you, though. Raise your hand if you want to share with me A. Okay, Brady.
X.
Not quite, not quite. Emily. 1. There's a 1 secretly in front of the x squared. That's our A. Raise your hand if you want to share with me the B. Alice. 2. Very good. Raise your hand if you want to share with me the C. Okay. Brady, you want a shot at redemption?
Yes.
All right, go ahead. This is 1. Very good, very good. Okay. I want you guys to try the same thing with number 3 here, okay? Nope. Thank you for asking, though. All right. What are we thinking is our A here? Who can tell me?
2.
Jack, what are you thinking? 2, I agree. Can anyone help me with the B? Raquel? Not quite. It's actually not 5. Who can tell me what's tricky about this one, Abby?
There's like the 7x, the 5 switch.
The 7x and the 5 switch. Is this one in standard form yet? No, this one actually really should be 2x squared plus 7x plus 5. So what's actually our B? 7. And what's actually the C then? 5. That was tricky. Okay, that was meant to be very subtle and very tricky here, okay?
I'm not happy anymore.
I'm sorry you're not happy anymore. I'm Mr. Castle. Nice to meet you. Okay. Any questions on number 3? So just, regardless of what order they're in, whatever would be second in the correct order is our B. Whatever's with the X to the first is our B. All right. So what we're going to learn now is we're going to utilize that step we just did in factoring a trinomial. We learned how to factor, once again, 4 terms. So what we're going to do is we're going to turn a trinomial into a 4-term polynomial. We're going to do this by splitting one of the polynomials. Okay, one of the monomials inside it. We're going to split one of the terms into 2, so that way we get 4 terms. Then we're going to do the same thing we did on the homework, where we group and go from there, okay? So our new thing today is going to be how to split, knowing what to split it into, those kind of things. So the first step is going to be making sure our trinomials in ax squared plus bx plus c order, as well as identifying our a, b, and c. So is this one in ax squared plus bx plus c order? Yes, it is. It's in our standard form. Now, what is our a, our b, and our c here? Okay?
7.
Ooh, what kind? -7? -15. Okay? Now, it says my step 2 is to fill in my x with 2 numbers that multiply to equal a times c and add to equal b. Okay, this is kind of weird, okay? But I want us all to draw an x over here, and the x should be big enough to where you could write a number in each of these 4 blanks. You should be able to write a number in each of these 4 blanks. Now, at the top of this x, this is going to be kind of like a puzzle here, okay? The top of this x, above the blank, we're going to put a times c. We're just going to write in a times c above the blank. We still want to fit something in the blank above it. Now, below the bottom blank, we're going to put b. Oh, someone must have written it there before. All right. So now we're going to say, what is our a times our c? 2 times -15 is? -30. So we're going to put that in the top, the negative sign and all. And what do we think we're going to put in the very bottom one? -7, because that's the b. Now what we need to do to figure out the other 2 sides is say, okay, what 2 numbers, 1, 2, are going to multiply to the top, -30, but add to -7. We need 2 numbers that fit this criteria. They multiply to the top, add to -7. Now let's think through some things here that can help us out. I'm going to walk us through some steps of how to process these. We're going to multiply to a negative. Okay, well, how do you get a negative number by multiplication?
Negative.
A negative and a positive. It can't be 2 positives, it can't be 2 negatives, can it? It has to be one of each. So we know already it's going to be a negative and a positive. I'm going to put the negative on the left and the positive on my right. That's actually going to help us out a little bit. Just make our life a little easier when we have one of each and the negative goes on the left. I'll show us why in a moment. Now, here, if we're going to add, it's kind of like a battery. If we're going to add a negative and a positive, what do a negative and a positive really do when they add? They really subtract. So they're really going to be 7 apart. Now, if they're going to subtract, and one's negative, one's positive, which number is going to be bigger, the positive or the negative here? The negative, because they're going to be going to a -7, okay? So those are kind of our thoughts.
I thought the positives were always bigger than the negatives.
Okay, as far as the actual value of the number, yeah, but we need the negative number to be the larger like integer right now. It's like if that makes sense. So, who can help me? Let's brainstorm some factors of 30. Okay, Abby.
Like the first one?
What do you know? Just what are the factors of 30 you're thinking?
1 and
Okay, 1 and 30. So we say, okay, 1 and 30. And if it helps you to write them down, we can write them down in some space somewhere and say, hey, 1 times 30. Okay, well, would that give us 7, negative 7? No, okay, that'll give us 29. Okay, who can give me another pair of factors? Eli. 6 times 5. Okay, that multiplies to 30. Would that give us negative 7 if we had them subtracting, though? They give us 1, not quite, okay. Raquel. 3 and 10. Would that give us 7? Yeah, and which one of those needs to be negative? The 10. And that 3 needs to be positive. So now we can double check. Would negative 10 times 3 give us negative 30? Would negative 10 plus 3 give us negative 7? The answer to both is yes. We filled out our little X here, our puzzle. What this is going to do is this is going to help us know how to split. So we're going to go back to this trinomial now. And like I said, we're going to split one of the terms into 2. So we have a total of 4. Elijah, do you have a question on how we fill this out?
Yeah. Are you going to be A times C always on the top?
Yep. Yep. Always, always, always A times C on the top and always, always, always B on the bottom. Yep. Now what A and C and B are will change, but it's always going to be those two and that. So we're going to leave the first term the same. And we're going to leave the last term the same. 2x squared and negative 15, those stay the same. The middle, we will split into 2. We're going to split the middle here into negative 10x plus 3x. Does anyone know why I just came up with negative 10x and 3x to split the middle into? Because those were the numbers we found in our x, weren't they? Those are the sides of the x. Now, why did I have to put negative 10x and positive 3x, though? They didn't have x's inside of the shape here. So why did I have to have that, Abby?
Because the 7 has the x.
Because the negative 7 has the x. Because if I were to add these two back, would I get negative 7x? Yeah. So did I really change the value of this? No. It's kind of like I just went backwards a step, isn't it?
Yeah.
Okay. It's like we just went to right before we combined like terms. So now, if we had a 4-term polynomial, what would we do if we were given this for the homework we turned in today? How would we factor that?
Oh, you would parentheses on the first 2 and the last 2.
Yeah, group them for parentheses on the first 2 and the last 2. And we're going to go the same thing we were doing. From here, it's the same thing we did. So what's our GCF of 2x squared and negative 10x? 2x. And then we're going to be left with x minus 5. Between 3x and negative 15 in the second parenthesis, what's our GCF?
3.
Plus 3, so we're going to put a positive 3 there. And what am I left with?
X minus 5.
X minus 5. Do we have the same thing in both parentheses? Good, we should, as long as we do it correctly. So what can I write now?
X minus 5 times 2x plus 8.
Very good. So did I turn this subtraction into multiplication? Yeah. And guys, if we were to FOIL it, do you want to bet what we come up with after we FOIL? The same thing we started with. You would get this first in the blue and yellow, and then we can combine like terms into what we started with, the original trinomial. Yes, it's a loop. So, was the grouping new to us? No. What was new to us? The x and the splitting part, right? Okay, that's the new part today. Everything else after that, we've done that before. We did that for today. The grouping and the splitting and the x was new. Now the x is a tool to help us know how to split it, what to split them into. That's what the x is for. It helps you figure out that. On number 2, our first step is to make sure it's in the right order and we identify A, B, and C. Is it in the right order? No, we need to put it in the right order. What needs to switch? Yeah, that negative 20x and the 4. So this should really be 9x squared minus 20x plus 4. So now we can identify our a, b, and c. So what's our a? 9. What's our negative? What's our b? As I say, what's our negative 20? What's our c? 4. Okay. So now what are we gonna do? Okay, make the x, and we got to fill it out. So the top's going to be a times c, and what's going to be on the bottom? B. So what is a times c? 36. Now, if you didn't rearrange it, you might think your c here was negative 20 instead, and that'd have been like negative 180. Ooh, got bigger. Okay. What's our b down at the bottom? Negative 20. So now here, as we're thinking through what do we have on the sides, that kind of stuff, we're multiplying to a positive. How do you get a positive by multiplying? Is it going to be a negative and a positive this time? No. Exactly. Negative, negative, positive, positive. Two are the same sign. How do we know which one is going to be both negative or both positive? Well, what are they going to add up to? Negative 20. Could two positives add up to negative 20? No. So what do they have to be? Two negatives. So we need two factors of 36 that add to 20, though, and we know they're both going to be negative. So the top number, you use the top sign to tell you whether they're going to be the same sign or different signs. If the top number is negative, different signs. If the top number is positive, same sign. Then you look at the bottom number to tell you, okay, now what are those signs? Or which one's bigger? Oh, I love it. We got it. Negative 2 and negative 18. And actually, it doesn't matter whether you do negative 18 and negative 2 or negative 2 and negative 18. But Abby's right that those two would multiply to positive 36 and add up to negative 20. No other factors of 36 would do this.
I was about to say that.
Oh, yeah, you're right there. I love it. I love it. What? So we want it to multiply to the top and add to the bottom. So they multiply to the top number. So negative 2 times negative 18 is a positive 36. And they add to the bottom number. Negative 2 plus negative 18 is negative 20. Does that make more sense to us? Yeah. All right, now what are we going to do? Now that we know the sides. Yeah, we're going to split the first one. We're going to split our original. Now, which ones stay the same? The first and last. 9x squared plus 4 stay the same. The middle splits, though. What am I splitting this negative 20x into? Yeah, negative 2x and negative 18x. Now do I have 4 terms just like we did on our homework? Yeah, we're saying, oh, all right. Easy job now. Yeah. Great question. It really doesn't matter. What would happen if you put the negative 18 first or the negative 2 first? It would just change the order of your parentheses at the end. So instead of having like x minus 5 first on the first one, you have it last. I'll actually show you that in a moment. Yeah, Courtney. Yeah, good luck. All right, 9x squared and a negative 2x. What do those have in common? X. So we're left with 9x minus 2. What about negative 18x plus 4? Okay, 2. And actually, what kind of 2 do we want to pull out here? A negative 2. Good catch, Elijah. And we'll be left with 9x. Why do I want to pull out a negative 2? Okay, we want it to be the same as the other one, and the first part of the parentheses is negative. We want it to be positive. Now, what do we get? We get 9x minus 2. So are the parentheses the same? Yes. Oh, yes, they are. So we pull that 9x minus 2 out to the front. And then we have x minus 2 in the other one. And we turn this addition and subtraction into multiplication. Yeah, Alice. Yep, did you do that? Okay. Did you end up getting the same answer, but the parentheses are flip-flopped? Okay, I'll actually show it right now, okay? Great question. That was the same question Eli was asking too. All right. Hey, listen real quick. I'm going to erase the left side here for a moment just to show you what would have happened here, because I got a couple questions on it, and I love that question. Mr. Goss, what would have happened if at the step where we had the negative 2x on the left and negative 18x on the right, if we swapped them? If we had 9x squared minus 18x minus 2x plus 4. Well, if we look at this, the first parenthesis will have a 9x in common, and we're going to be left with x minus 2. Second parenthesis has a negative 2 in common, and we're left with x minus 2. So we pull the x minus 2 in front, and we have the 9x minus 2 in the other parenthesis. So what happened from here compared to the original? They just flipped. What's in the parentheses are still the same. They just flipped the order. And that's perfectly okay. Those are the same answer. That's the only thing that changes there. Now, on another problem, like on the first one we did, if we had the 3x first and the negative 10x second, would we have had to factor out a negative number out of the second parenthesis? Yeah, because it would have started with a negative. That's why I like having the negative come first when we do one of each, because then you don't have to factor out a negative number usually. It makes our life just a little bit easier. All right. Let's look at number 3 here. Josh, what's my first step on number 3? X? Okay, well, actually one thing before the X. Do we have it in standard form? Okay, and then do we need to write out our A, B, C every time if you know? Probably not. That's a step we can start skipping if you're comfortable. Okay, Josh, let's do that X. What's going to be at the top of this X, guys? Negative 24. And if you're more comfortable, once again, still writing A times C so you remember what's up there, feel free to. Yes, Abby? Great question. So it being A versus X, that's okay. It's just going to change at the end. Instead of having X's, we're going to have A's as all. Yep, great question. Now at the bottom, what's going to be down there? 5. Now we're multiplying to a negative. So what kind of numbers are we going to have? Double negatives will give us a positive. One of each, a negative and a positive. Now I'm going to prefer to put that negative on the left-hand side. This makes our life slightly easier. And we know the bigger of these two numbers is going to be positive or negative. Which one? Positive, because it ends as a positive 5. So what are two factors of 24, that actually subtract, because of different signs, to 5? Abby Dasher. 3 and 8. Very good. And you said that negative 3, positive 8 in that order, because it would be in that order here. A negative 3 and a positive 8. Now, if you're having trouble filling out these on the side, you're like, wait, how are people getting these so quickly? Okay, that's probably some of us in here. Feel free to write these factors out to the side like we were the other day, okay, a few lessons ago, until you find the pair that works. All right, now what do we do? Okay, 12a squared and the negative 2 stay the same. And what do we do with the other?
Negative 3 plus 8.
Yeah, negative 3a plus 8a. Now, as we get more comfortable with it, you might just start writing it in order, knowing you're going to split the middle. But if you're more comfortable still just kind of doing the first and outside and then the middle, that's okay. So now what do we do with 4 terms here, guys? Yeah, we keep grouping it. I want you guys to go ahead and finish this one off. When you have it or have questions, raise your hand. We're going to keep talking about this one up here, though. You go to the restroom. Here, good luck. All right, so we group these first 2 and the last 2. And what's our GCF of 12a squared minus 3a? 3a, very good, Jack. And we're left with 4a minus 1. And then out of 8a and negative 2, what's our GCF? 2, very good. And we're going to be left with 4a minus 1. Now that 4a minus 1 is the same in each, which is really awesome. Because we're able to say, hey, that goes first. Then we're going to be left with 3a plus 2. We could always double check our work by FOILing. And we would get where we started. Questions on number 3. Okay, if you haven't already, I want you to try 4. So thankfully we don't have to rearrange anything because, like I said, it is in standard form. Jaden, I'm going to make my x, and what number is going to go at the top of my x here? Negative 12, very good. And then Elijah, I said that weird, Elijah. Anyway, Elijah, what's going to go at the bottom? Negative 4. And what two numbers that multiply at the top, add to the bottom. And we know the signs are going to be a what and a what? A negative and a positive. Josh, what two numbers are you thinking here? Very good. Negative 6 and positive 2. He nailed it, okay? Those would subtract, really, or technically add to negative 4. Now what we're going to do is, who can tell me, actually, what to rewrite as my 4 terms? Okay, Jaden, you got this?
3y squared minus 6y plus 2y minus 4.
Nailed it. The first and last are the same. That middle one split into the two sides of the x. Now we group the first 2 and the last 2. 3y squared minus 6y. Put it away, Sarah. Put it away, Abby. All right, what is our GCF of those two? 3. Why? There was a variable though, right? And then we're going to be left with y minus 2. What's our GCF of 2y and negative 4? 2. So we're going to pull out a positive 2. And we're with y minus 2. Is it the same thing in both? Gucci. So we pull that out in the front. And our other one, we have 3y plus 2. Questions on that? Alrighty. Let's continue on to this bottom part of this, okay? We won't do all of these. We'll do a few. So, we also want to check to see if a trinomial has a GCF before we start, okay? So, just like on our homework a few days ago, flashing back here to 7.1, where we just looked for a GCF of everything, and we said, hey, even 2 or 3 terms we look for GCFs in. We want to check to see if there's a GCF first before we make our x. And then a special note here, we're going to encounter some polynomials that just can't be factored. I'll talk about how you know it can't be factored, okay? And if so, we'll say it's prime. Just like a prime number 7 can't be factored into any numbers but 7 and 1. We'll see when a trinomial is prime. Now, if we look at example 1 here, 3r squared plus 12r minus 63. Is there a GCF out of the 3, right? And so what we're going to do is, do we really want to multiply 3 and negative 63 and find factors of that? No, okay? And actually, even if we were to do that, we'd have to do the step at the end anyway of taking 3 out. So it'd be much more beneficial to do that now. So if I factor out a 3, I'm going to be left with r squared plus 4r minus 21. Now, when I identify my A, B, and C here, I'm going to use these numbers inside the parenthesis. Okay? I'm going to use the numbers inside the parenthesis for this one. So what's going to be my A, B, and C on this one? A is 1, B is 4, and C is negative 21. So when we make our x here, we put A times C on the top. What goes at the top? Negative 21. And what goes at the bottom? 4. So we need 2 numbers that multiply to negative 21. So a negative and a positive. Emily, you got these? Nailed it. Negative 3 and 7. Negative 3 times 7 gives us negative 21. Negative 3 plus 7 gives us positive 4. So now we're going to split these 3 terms. But we still have this 3 on the outside. We can't forget about that. That 3 is going to be there every other step of the way. So now we have the inside of the parenthesis, r squared minus 3r plus 7r minus 21. Anyone? Yeah, so it's and then we're going to have to do a double parenthesis inside of that. Very good, Jaden. And so once again, we're still going to have that 3 on the outside of everything. And what's our GCF between r squared and negative 3r? r. And we're going to be left with r minus 3 on the inside. Yeah, this kind of gets messy, doesn't it? Having to write big, yeah. Or maybe write small to fit it all in. What's our GCF between 7r and 21? 7. Positive 7, so we're going to be left with r minus 3. Now, inside these smaller parentheses, do we have the same thing? Yeah. So we're going to pull that out in front, but it's still going to be inside the big parenthesis, okay? So when you say out in front, it's still going to be inside this big parenthesis, okay? So we're going to be r minus 3, and then the r plus 7. And so actually, when I say out in front, it doesn't have to be inside the big parenthesis necessarily, because we don't need the big parenthesis anymore. It just has to be in its own parenthesis, but it's going to be after that 3. So if we were to multiply in the 3, pause, and then FOIL them together, we would get what we started with again. But if I didn't have that 3 there, and we FOILed it, would we get what we started with? No, we'd get what was inside the parentheses to start. So that 3, make sure we keep it at what it was originally. We're not actually changing it now, we're just changing how it looks. We're giving it a glow up like we talked about. Questions on that? Mr. Costle, what would happen if I didn't take the GCF out right away? Well, let me show you. Thanks for asking. So you have these massive numbers, and don't write this part down, okay? So you have these massive numbers, and you have 3 times negative 63, which is a negative 189, and you have to add up to 12, and to figure out a negative and a positive that get to that. Isaac, did you end up finding those earlier?
Yeah, it's negative 9 and 21.
Okay, negative 9 and positive 21. I agree with that. Hey, did we notice actually that these are exactly 3 times bigger than our numbers over here?
Yes.
And what was our GCF originally? 3. Hey, is there a coincidence? Is there maybe a pattern there? Okay. So if we were to split these from there, we would notice we get 3r squared minus 9r plus 21r minus 63. And we group. We have a 3r. We have r minus 3. And then we have a plus 21. And we're left with r minus 3. Then we say, hey, those are the same. And we have r minus 3 and a 3r plus 21. Now, does that look at face value like the same thing as this, though? No, the r minus 3 is the same. But that second parenthesis, 3r plus 21, it's like we multiplied this parenthesis by 3. Once again, not a coincidence as 3. But in this parenthesis in here, could we still factor out a GCF? Of 3, right? So we would do that, and we take out that GCF, put it way at the front, and say, okay, we still have r minus 3, and then r plus 7. So do we end up getting the same thing? But which one is going to be probably easier? Doing it early and getting smaller numbers, or doing it late, getting bigger numbers, and honestly, we risk forgetting about it? Probably early, okay? So it's good to look for it right away. Questions on that? Alrighty. Let's look at number 2 here. Is it in standard form already?
I feel like it's prime.
Okay, is there a GCF? No. Okay, so let's make the x. What's going at the top of this x? 7. 1 times 7. What's going at the bottom? 5. Now, it's multiplying to a positive, so it's going to be either 2 positives or 2 negatives. And it's adding to a positive, so it's going to be 2 positives or 2 negatives. 2 positives. Now, what are the factors of 7, guys? 1 and 7. Would 1 and 7 give us 5, though, by adding? No. So can we complete the x? No. So that's prime. So it's not necessarily just because 7 is a prime number. That's not necessarily why this happened. You can have prime trinomials even when you don't have a prime number like that. What happened here is you can't complete the x. That's how you can tell if it's prime. When you can't complete the x, you can't actually make factors for it. Okay, does that make sense? Okay. So whenever you can't complete the x, you can't make factors for it. It's not necessarily just because that 7's prime. All right. Number 3. Actually, I'm going to have a skip number 3. I want us to look at number 4. You want to start us off? All right, what do you notice in Abby?
Okay, 2 is the greatest common.
Very good. We have a greatest common factor of 2. So that means we're going to have to keep writing that 2 the entire way through that. So 2 is going to be on the outside here. And what's going to be on the inside now?
X squared plus 6x plus 8.
Very good. Very good. And honestly, I like dealing with that because it's much more manageable. Good luck, Jack. Now we're going to make our x. What's going to go at the top of the x? Very good. 8. We have to go inside the parenthesis 8 times c. What's going at the bottom of the x? 6. Very good. And now, what's going to be on the sides? 2 positives, 2 negatives, a positive, negative. And what are the numbers? Emily? Both positive, and it's 4 and 2. Does it matter whether you put 4 and 2 or 2 and 4? No. Elijah?
Wouldn't the bottom number, or no, the top number be 9, 8 plus 1, or no, is it more?
So we would do a times c on the top. Yep. And if it'd be better for us to write out a times c at the top to help us remember, that'd be a good idea. Thanks for asking. Bless you, must rain down after this forget. So now, we're going to have that 2 on the outside still, and we're going to split the middle. So we're going to have x squared plus 4x plus 2x plus 8. And if your neighbor, let's say you're comparing work, and your neighbor put the 2x first and the 4x second, you get the same answer at the end, just flipped. Okay, so your in-between steps are going to look a little different though. So we group these again, first 2, last 2. We write that 2 out in front. And what is our GCF of x squared and 4x, Alice? X, very good, and we're going to be left with x plus 4. Ava, what's our GCF between 2x and 8 in that second parenthesis? 2, very good. So we're going to pull out a positive 2, and we're going to be left with x plus 4. We notice inside the parenthesis we have the same thing. So I'm going to put that 2 out in front of everything else, and I'm going to put the x plus 4, and I'm going to put what's left, the x plus 2. And that's our answer. Questions on that? Yep, you need a second? Yep, thanks for telling me. All right, we're not going to fully do example 5, but we will fully do example 6. I'll talk about example 5 real quick, though.
Okay, can I ask, I know we didn't usually, but can I ask you a question on here?
Yeah.
Okay. Well, I'll ask you, because I have to show you.
Okay, that sounds good. All right, everyone good on this one, example 4? All righty. On example 5, are we ready to go right away? No, what do we have to do?
Move it around.
Move it around, right? We'd have to make it 6b squared, what? Minus 13b minus 5, okay? Very good. That's the only thing that would be different on 5, another curveball in that way. Once you do that, it'd be everything as normal. Okay? I'm not going to have us do that right now, though. Oh, what was that? Put it in standard form. Yep. On 6. Wait, what's different about 6 here? There's 2 variables, and so then we have an x squared and a y squared, okay? It's actually not going to affect us too much of what we do, okay? So we'll still do our normal A, B, C. Is it in standard form? Yeah, it is. Okay, so we'll still do our normal x. What's going to go at the top of the x here? Okay, 20. 5 times 4. What's going at the bottom? 21. And are these numbers going to be positive, negative, one of each? Positive, multiply to a positive, add to a positive. Okay, and what 2 factors of 20 add to 21? 20 and 1. Kind of like a trick question. Go ahead and keep trying to keep going here. So where we left off was how to split it. We finished the x, but now we need to know how to split it. Well, the first and the last term are still saying the same, and we're still splitting that middle. So we're going to put a plus 20 and a plus 1, but what are they going to be? A plus 20 what? XY. And a plus XY or a 1XY. See, Ellie? So now, as we do our GCF, everything's going to be like we saw on our homework in this section, okay? So did we see, not our G, we do our grouping. Did we see grouping problems like this when we have 4 terms? Yeah, we did. So what's going to be our GCF between 5x squared and 20xy? 5x. And what are we going to be left with? X plus 4y. And then what's our GCF of xy plus 4y squared? Just a 1y. So we're going to pull out a positive y. And we'll be left with x plus 4y. Are the insides of the parentheses the same again? Gucci. So we put that out in front. And we're left with 5x plus y. And we successfully created multiplication from addition. So the only thing that really changed on the last one was we had to make sure to make the middle term be x, y. The middle term is just going to share whatever variables it already had. Yeah, Abby?
On the x thing, I put a 1 in there.
Yep. And so did your parentheses just flip around for mine?
Yeah.
Yep. So that's exactly okay and perfectly good. So Abby said, hey, Mr. Crossell, I had the 1 and then the 20 for the x on different sides. Is that okay? Yeah, it is. As long as you do it correctly, your parentheses are going to be flopped. Now, Abby, in the middle here, when you went to this blue step where we pulled out the GCFs, were your GCFs different than mine?
No.
Yeah. Your GCFs were probably x and 4y, weren't they?
Yeah.
Yep, and that's going to be okay. Yep. Any other questions on that? Yeah. Yep. All right, real quick, guys. On this worksheet, I want you to do the evens only. Only the evens. Sound good?
Yeah.
Gucci.